final exam setup, you'll have a wire coming out the wall. You'd have to hook it up to the oscilloscope to see if there's a DC offset or not. And you also have to measure the period, describe what kind of a wave it is, square wave, sine wave, describe the amplitude. You have to be able to measure that. How do you check whether there's DC offset or not?
Where the thing starts, like that.
Sure. What if the thing? So, what is the DC offset? Suppose you have a sine wave. What's the DC offset? Suppose you have 0 volts DC offset, so no DC offset. Then your sine wave is going to oscillate about ground. It's going to pick on its maximum amplitude above ground and its minimum amplitude below ground. Suppose it's a DC offset of 5 volts. That just basically pushes up the sine wave. That makes the sine wave oscillate about 5 volts instead of about 0 volts. So it's basically adding 5 volts to each of the points on your sine wave. That shifts up the entire sine wave. In your oscilloscope, there's a setting called AC coupling and DC coupling. Those are the switches. You can either put it on AC, you can put it on ground, or you can put it on DC. If you put it on AC, then you don't see any DC offsets. Refer back to your old labs to remember that. If you put it on DC, then you do see DC offsets. So that's the advantage of having an AC coupling mode and a DC coupling mode. Okay, so as far as connecting circuits together goes, if you're measuring voltage, how do you connect the voltmeter to your circuit? You connect it in parallel, right? So if this is your voltmeter, you want to measure the voltage across the resistor. That's how you connect it. And the resistor is powered by a battery. You'll be also asked to draw circuit diagrams for stuff. So you have to be familiar with the symbology. Jagged lines are resistors. Something describing a V is a voltmeter. Something describing ohms is an ohmmeter. Something describing an A is an ammeter. And a short line and a long line is a battery. The short line stands for the negative. The long line stands for the positive terminal of the battery. So if you have a system like this and you want to measure the voltage across R1, that's how you do it. But you can also have a system with multiple resistances, and it can come in 2 forms. Either the resistors are in parallel or the resistors are in series. And of course you can have combinations of them, that's fine. The idea is to break down your multi-resistance system and bring it to a single resistor form. That's why you calculate equivalent resistances. So suppose you have a resistor here, and you're powering the circuit with your, what do you give power to your circuit with? DC power supply, right? Right. You want to always put in your cables from the positive terminal, power your circuit, and complete your circuit on the negative terminal. Do not try completing it on ground, because all your readings will be off by a factor of half. Okay, so R1, R2, what's the equivalent resistance? If you treat both of these as one resistor. What's the equation for adding resistors in parallel? Exactly, so 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus how many ever there are in series. So if you have an R3 there, then it's plus 1 over R3. This is your equation to find R equivalent. Notice that it's the reciprocal. It's not R equivalent is equal to 1 over R1 plus 1 over R2. That doesn't make any sense because the units are wrong. So if you're trying to do that and you're not sure, look at your units, see if it makes sense. Okay. If if you're adding, so this is in parallel. In series, you basically have a circuit, with multiple resistances, one off the other. How do you add resistors in series?
Just add them.
Normal add. R1 plus R3. That part is fairly simple. Okay. Another thing you'd have to know is that the current in a circuit is always constant. Can someone tell me an example where the currents in different parts of the circuit are not equal to one another?
Make it split.
Sure. Make it split. And what do you do with the split? How does the current know what fractions is split by?
Based on the resistance.
Exactly. So you can have a battery, and you have a current, and you can split the current. Suppose R2 is much bigger than R1, most of the current would go through R1, right? And suppose R2 is much smaller than R1, most of the current would go through R2 because it's the path of least resistance, literally. So we just calculated the equivalent resistance of something like this. But remember that the current at this point splits into two different current components here. So let's call this I2 and I1. The truth is that the currents meet back up at this point and give you back total I, where I is equal to I1 plus I2. So after splitting up and all that, they somehow recombine because these are the kind of circuits you're going to deal with. And after recombining, you get back the total amount. Nothing is lost. That's the conservation of charge. Based on this principle, let's say the total current is I. How much does the current drop by here at this point? Nothing, yeah. So the current doesn't drop. So if I, how much does the current drop by here?
Nothing.
Still I. Because you're basically shoving in all of these electrons through this highly resistive path maybe, and the electrons are going to have a bad time, and shit will be really slow in here. But everywhere along this conductor, there's always electrons. That's why when you switch on a light, the light comes on really fast because the closest electrons to the light is what's completing the circuit. It's not like as if you traveled super fast and then turned it on. If you actually measure the mean velocity of the electrons inside a metal, it's kind of slow. It's pretty fast, pretty damn fast, but it's not as fast as you turn on a light. Okay. Using the principle of potential, if you supply a DC potential of V volts, the potential drops by a certain amount across R1 and drops by another amount across R2, right? That's Ohm's law. V is equal to IR. But R is equal to R1 plus R2. And that's what V is. What this is saying is that if you go in a loop around your circuit and include the voltage provided by the battery, then the sum of the voltage provided by the battery and the voltage lost by the resistors is equal to 0. So whenever you're going from negative to positive terminal, this is for your theory part. You're going to have a practical part and a theory part. Theory part, you have to be familiar with stuff like this. Practical part, if by now you guys have been are good, then you'll be fine. If you're in the woods, then I don't know. I'll send out an email offering you a chance at practicing stuff with some other people's lab, but I don't promise you that might happen. Okay, so if you went from minus to plus, you add this voltage. Then you lose it across this resistor, so you get a minus IR2 here and a minus IR1 here. And a plus V here. So minus IR2 minus IR1 plus V is equal to 0. You recover back Ohm's law from that. Okay, that's kind of where it comes from. Great. So considering the fact that the current is constant at all points of this wire, let's say you put in 2 voltmeters, one over here, call it V1, the value that you're measuring is V1, and V2 here, these are voltmeters. What value does V2 read? How do you begin to solve that problem? So the current is the same here, current is the same here, current is the same here. And usually the internal resistance of a voltmeter is very, very, very high. So no current wants to flow through the voltmeter. All the current wants to flow through R2 so that the voltmeter can accurately measure the voltage drop across R2 and not across itself and stuff like that. In your second lab or third lab, you had the case where you had the internal resistance. In that case, these two are just in parallel. So you come up with an equivalent resistance for both of these and then answer the problem which I just posed to you, which is what voltage does V2 read in terms of R1 and R2? Does anyone know? Alright, so whatever voltage is dropped here and whatever voltage is dropped here, when you add them together, they should equal V, right? That's one equation. Okay, so the current is constant, right? So you have V is equal to I R1 plus R2. So your current is equal to R1 plus R2. Okay, and your voltage drop across this guy is IR2, right? V is equal to IR, so V is equal to IR1, V is equal to IR2 for each of the resistors. So the voltage drop across R2 would just be I multiplied by R2, which is V times R2 by R1 plus R2. Same thing for here. The voltage drop over here is I multiplied by R1, so V times R1 divided by R1 plus R2. What happens when you multiply add V1 to V2? What happens? It just becomes V, right? So if you look at these equations and you add this quantity to that quantity, R1 plus R2 and V are common in both terms, so you just pull them out, and in brackets you have R1 plus R2. And so you can divide out R1 plus R2 and R1 plus R2 to get back V. So everything is consistent in this universe. So this is something really important. Know why these equations happen. Your book just gives them to you, but they skip the important step, which might sound obvious but really isn't, which is that the current is the same everywhere on the circuit. So that's lab 3 stuff. The rest of it is algebra. You're adding on complexities. This is the fundamental thing. If you have some internal resistance here, Ri, then obviously the current is going to split through the internal resistance in R2. Usually Ri is basically infinite, so all of the current goes through R2. But let's say R2 is comparable to Ri. What's the equivalent resistance here? Whoever answers this might get a bonus point on their last lab report.
You said the question one more time.
So you have R2 here, Ri here, which is the internal resistance of the voltmeter. What's the equivalent resistance of R2 and Ri?
It's just a parallel resistor. 1 over R2 equals 1 over R2.
Sure, what's the answer? Yeah. So R equivalent, so So 1 over R equivalent is what you guys just said, 1 over R2 plus 1 over Ri. If you do a bunch of algebra, which you really should be familiar with doing, otherwise it's little to no hope, is Ri multiplied by R2 divided by Ri plus R2. That's the answer. Okay. If you do the math, you'll get that. Yes, no one gets a bonus point? Which I was kidding about. I guess that's it. Like, just know this stuff. Go. If you have any more questions, shoot me an email. I'll do my best to answer. You don't need to worry about, complicated future lab stuff like frequencies and all that. Don't worry about it. With your oscilloscope, be sure you know how to measure amplitudes and frequencies. Be sure you know how to check whether there's a DC offset. If I were to check DC offsets, I would just put it on DC mode. So I'd first put it on AC mode, see where the wave is, and I'd put it on ground, see where the wave should be oscillating about, basically where 0 volts is, and then I put it on DC. If the wave shifts away from where it was, then it's all being shifted by a constant DC offset. It would be great if you guys get this question on the exam. I really hope you do. So apart from that, I'm not sure what other kinds of stuff they can ask. It'll all be, permutations of questions like this. Maybe they'll give you V1, you have to solve for R1 using these equations. Like the way I did it right now, I didn't pose a problem and come up with a solution to that problem. It was more like, oh, these are facts, these are facts, these are facts, be familiar with these. You have to be familiar with problem solving. Like, you have to be able to use the facts to your benefit. I only told you the facts. The slightly more tricky part is to know which facts to use to solve a problem. So I hope you guys study and do that part nicely. If you have problems, just send me an email. We can fix the time to meet.
So the material of the practical is only on